Hi, my name is Jennifer, and I have just completed Module 2, my Inquiry Lab. Can you filter your water? I used the materials, of course, the dirty water, sand, gravel, carbon, alum, and cheesecloth. I created a stackable filter system, and I put alum at the top, then sand, gravel, and charcoal, which would lead me to have a container of clean water. This was my prediction. The reasons for my order of materials: I chose alum first because I thought it would clump the dirt and particles together. Then I chose sand because I thought it would get rid of the dirt, and the gravel would catch all of the larger pieces, and the small particles would pass through. Finally, I thought the charcoal would clean the water because it would change the water from a darker color to a lighter color. And here's a picture of my dirty water. Here's another picture of the order in which I placed all of the materials: alum, sand, gravel, and of course charcoal at the bottom. In the end, this is what my water looked like. This was not what I was hoping for. However, it started out to be a very dark brown in color, and it became a lighter brown. I was hoping that I would not see any brown, but of course it is a light brown color. On the inquiry continuum, essential feature number 1 states learners are engaged in scientifically oriented questions. I believe this was teacher guided. To start us out with our activity, the learner engages in question provided by the teacher or materials. Number 2, the learners were given priority to evidence, which allows them to develop and evaluate explanations that address scientifically oriented questions. When looking at the continuum, I believe this is learner self-directed because the learner is directed to collect certain data. Prior to completing the activity, I needed to look at a map and determine some data information based on the location of my school. Number 3, the learners needed to formulate explanations from evidence to address scientifically oriented questions. Again, I believe this was learner self-directed because the learner was guided in the process of formulated explanations from evidence. There were questions that were posed which allowed me to think through the process of how I was going to work through the process. Finally, the learners evaluate their explanations in light of alternative explanations, particularly those reflecting scientific understanding. Again, I believe this was learner self-directed because the learner is directed toward areas and sources of scientific knowledge. Number 5, learners communicate and justify their proposed explanations. It was again learner self-directed because the learner was coached in the development of communication. Throughout the entire process, the teacher did not give full explanations on how to complete the activity. Materials were given, and as a learner, I needed to come up with a plan of how I wanted to create my stackable filter. And then I had to answer questions posed by the teacher in order to get myself to the end of the activity. And as I continued through the activity, I was thinking about, am I doing things properly? Did I choose the right order in which to place the materials? And getting to the end of the activity, I realized that I should probably go back again and figure out another order in which I would place the materials to find a better way to filter the water that was very dirty at the beginning and getting me to cleaner water at the end. And part of the STEM process is to try again and try to come up with a solution to a challenge or a problem. As teachers, we should not give students the answers how they get to an end point. It is our job as teachers to present learners with a problem and see if they can work together in groups or individually, preferably with groups, and how to reach a problem given a certain set of materials. And hopefully they can reach that end result. If not, it is our job to encourage them to go back and look at where the breakdown was in the design process and the implementation of the design in order to find out a workable solution to the problem. And that's it.